Alright, CNT120, we're on the section right after port numbers where they talk a bunch of different applications. And they give you a little teeny blurb on these. So let me give you just a little bit of information on each one so you can start to sort them out. There's a number of different applications that are part of TCP/IP. There's a whole bucket of them. And they give you a sample of a couple of them in here and what function they serve. Well, TFTP, the first one they mentioned, Trivial File Transfer Protocol, it's at the application layer. Its function really is to transfer very simple amounts of data, more trivial than FTP, to a device like a computer, like a router, like an IP phone on startup. Here's some configuration that you need. That's what TFTP does, and it does it connectionless. It does not guarantee it's going to get there. It just goes, here is the file you wanted, boom, 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 boom. It's usually a very simple text file, and here's the information you need. And this is useful for, I'll give you an example of a router network. I might actually save my router and switch configs over to a TFTP server. And a router config kind of reminds you of just a series of lines of text. This port, this IP, this port, this IP, this routing protocol, this network. Very simple. And that can get saved to a TFTP server. So all of my configuration, my networks are in a secure, or I should say, centralized location. Centralized location is the phrase I was looking for. NTP, Network Time Protocol. This is the way you can synchronize all your network clocks, and that can go for routers, that can go for switches, that can go for servers, that can go for desktops. And this actually communicates with an NTP server to get up-to-date, accurate time, so you don't have to worry about a static time on a device. Okay, it actually communicates out to an NTP server. NTP server responds with, here's the correct time. Well, just for fun, let me show you this, because all these protocols work along those lines. I'm going to start my Wireshark up here. I'm going to put a filter in for NTP, so I'm only going to see NTP. I'm going to start a new session. Okay, I'm starting a brand new capture. I'm going to grab the clock settings. That's it. I'm going to grab the clock settings for my machine. Right now it's set for set automatically is turned for off, so I can manually change my time. I'm going to turn that on, and when I do that, you're going to notice it immediately talks to a server out there, and the server responds with my time of Monday, blah, blah, blah. Just proof that there is a communication from me to a server and server back to me to set that time. And there is your NTP protocol. It's giving you an actual timestamp of date, time, etc. NTP is how your clocks on computers, servers, routers can be maintained from a server somewhere. So everything's running the same timestamp instead of having to set all these manually. That's what NTP is about. And a lot of these protocols fall in that category. LDAP, Lightweight Directory Access Protocol. This is here for dealing with network-based directories on things and interconnection. So a user logs in and you have a server like an Active Directory server that might communicate with a bunch of other resources sharing permissions or access to. LDAP is a way to do that. So I can sign into one entity, and that entity, that Active Directory server, can authenticate me to a bunch of other pieces or set permissions to a bunch of other pieces, saying, okay, on this thing you have access to this, on this thing you have access to this, on this thing you have access to this. That's what your LDAP is for, or that's what it can be used for. SMB, Server Message Block. This was used for like file sharing, peer-to-peer kind of thing in early Windows networks. And on Unix versions, there is a Samba server on Unix and Linux systems for file sharing. And this actually can be set up to share files between operating systems, your Samba server, SMB server. Once upon a time, we used to do that lab as far as peer-to-peer setup. SIP. This is a protocol used for multimedia, video and voice usually, and this protocol is used to set up the communication session. Say, hey, ring ring, are you there, so to speak. And once it's set up, then another protocol usually kicks in to carry the voice payload or the video payload. And this is very common in voice and video calls. And here's just a sample showing you, hey, I'm going to invite you to a call. Once it's connected, the actual transfer is done by another protocol, usually RTP, and then the SIP kicks in again to say, okay, goodbye, and close out the session. So that's your signaling protocol. H323, same idea as SIP, and many cases SIP has replaced H323, but it's the same idea. They're to set up, carry the data, carry the communication, then shut it down. That's what that's really there for as well. All of that falls under an umbrella of, with our protocol analyzer, just like I showed you a little bit ago with NTP, I can gather or grab these packets and analyze them using a protocol analyzer, a packet capture tool, a packet sniffer tool. And Wireshark is our example that we use in lab, and we use in lab quite a lot, that looks very much like this, or like I was just showing you right here, this right here. It allows me to grab these packets real time and then open up and start looking at the header fields to see what is this thing doing, where is it going. So it allows me to gather those and actually do quite a bit of learning from them. In a network scenario, a lot of troubleshooting from them. Alrighty, we'll come back to the next one, talk about domain names.